Let's now consider a second example of a function. And for that, we start with the following definition of the function h, which maps real numbers into real numbers, and every x within R is mapped into h of x, and h of x, well, it's a number living in the real numbers, but what number is that? Well, it's 1 minus x squared. What is the procedure which is contained in this definition? So let me write it. We have h, should be careful, is a recipe. What recipe is embedded in this thing? You can extract this recipe by focusing on this calculation and try to see what is the things that are being computed. If you give me an x, what is the first thing that we should compute here? Well, it's x squared. So probably the first line of this recipe is to compute x squared. Or should I say, to multiply the input by itself. As a second step, after you have x squared, what is the second thing that you compute? Well, we subtract from 1 the result, x squared. So this is a second line. So h is a two-step recipe, which is multiply the input by itself, and the second step is to subtract from 1 the result 1. So the result from the previous step. Can you see? It's very important to recognize this, to understand, to go from year to year, because it doing so makes you realize that things are computed here in a certain order, and that could be important for the interpretation of this thing. Okay, this is the recipe that acts on the real numbers here, but what is in turn h of x? Well, h of x, let me just, so when it's h acts on x, let me put in another color. When h acts on x, now you get a number, but what number is this? Well, instead of the input, well, the input now is the number x that we chose. So it's multiply the x by itself, and then subtract 1 from the result, the previous result. So this thing here is also a number. This is a symbol for a number that lives in the codomain. H of x is just an abbreviation. And moreover, 1 minus x squared is also an abbreviation for this entire thing. So we are abbreviating all the time. Can you see? Different ways of explaining what is the number that lives here, which is in turn assigned to this thing. Well, now that we have the procedure and a better understanding of what this thing is supposed to mean, let's now try to make a graph for it. And for it, let's make, in fact, let me do it like this. I'm going to give you the graph, and then let's try to relate what is the information which is in the graph and with this. Because this graph is a little bit more complicated. So we have the horizontal axis and the vertical axis. This is where x lives. This is where h of x lives here. And the graph is like this. This is minus 1, this is 1, and this is also 1. It looks like a mountain. This works more like this. Not a vertical line, so it's a mountain. Can you see? Let's now try to relate this with this information here. What do we see? Let's see. What do we see? Well, when x is minus 1 or when x is 1, h is 0. Can you see? Let's try to verify that. H of minus 1 is equal to 1 minus 1 squared. But minus 1 squared is 1, so it's 1 minus 1, which is 0. So it's confirmed. The point here, minus 1, 0, belongs to our function h. And as a result, we have this point here. You see, if instead of minus I put here a plus, this should be a plus, but 1 squared, but the positive 1 squared is also 1, so we get again another point. 1, 0 also belongs to h, and as a consequence we have this point here. What about this one? Well, we know that x is 0, so when h of 0 should be 1 minus 0 squared, which is 1. As a result, what we see? We see that 0, 1 belongs to h. And isn't that the coordinates of this point, the top of the mountain? Moreover, looking closely at this thing, 1 minus x squared. If x is between minus 1 and 1, then x squared is smaller than 1. This is very important to see. I hope you can see this, because if x, let me give an example. Well, imagine that x is 1/10. If you square this thing, then you get 1 over 100, which is it's smaller. It's smaller than 1. Can you see? So in general, every single x that lives between minus 1 and 1, excluding the minus 1 and 1, x squared is smaller than 1. And as a consequence, 1 minus a number which is smaller than 1 makes this thing here a positive thing. And that's what you see here. For every x between minus 1 and 1, all the y's are above the horizontal axis, because all the y's are positive. Moreover, when x is exactly 0, we are at the top. You see, because you are always subtracting from 1 some number. The minimum number that you can subtract from 1 is 0, so you get the maximum of this thing. Can you see? Now, what happens when x, instead of being between minus 1 and 1, is outside? So it's from minus infinity up to minus 1, or it's from 1 after 1 up to plus infinity. What happens? In those circumstances, you see, x squared now is above 1. You see? Because, for example, imagine that x is equal to 2. Then you get 2 squared, which is equal to 4, larger than 1. Can you see? Or if minus 2 squared is again 4. So all numbers, all x's that are after 1 or below minus 1, makes x squared a number larger than 1. And so we are subtracting from 1 a number which is larger than 1. So as a consequence, this thing here now is negative, just like you see here. All these points, all the y's of these points, are below the horizontal axis. They are negative. Can you see? So this is how you understand. This is why it's also important to, when you look at this thing, to understand what are the calculations which are involved. That is the procedure. Because just from the analysis of the things that we are computing here, you can now understand the generic behavior of this function. You see? One more observation. What now? What is the domain of the function? The domain is already, you already wrote it. The domain is the entire real numbers. So it means every x here on the horizontal axis belongs to the domain. But what is the range? See, this is the codomain, the entire vertical line. But what is the range? Now that we know the graph of the function, we should ask what are the y's. What are the y's of all these points here on the curve? Well, at most, it's 1. So this, or these points. So these y's also, because these are the coordinates of these points. So all the y's, well, is from 1 up to minus infinity. Can you see? So the range of our function h goes from minus infinity up to 1, including the 1. Can you see? And of course, this is a subset of the codomain here. Can you see? One more time. Once again, we can only arrive at the range after we have rough knowledge of how the function behaves, and that in turn comes from understanding what this thing is supposed to mean, and after some calculations. Okay. Finally, one final commentary. Notice what I wrote here, what I drew here. It's a curve. It's a mountain. It's our mountain function. This is the top. This is the, but this function has no bottom. You see, the part of the mountain underneath the ground. So this is the ground. The part of the function underneath the ground has no end. So what I drew here is just part of the function. So I only drew part of the order pairs in H. Because the function has no end, so I cannot not draw everything. But at least I was able to draw the important part. Because you see, after this axis, after this axis, the function does all the same thing all the time. It just goes down and down and down. For x below minus 1, it goes down, down, and down. So nothing quite relevant actually happens. Where the important thing happens is close to the critical points. So the zeros and the maximum here. Can you see? Where is the top? So this is an important idea to realize this, because I only draw the part of H. And at least I drew the important part. And the important part is usually close to the critical points, where this thing is 0 or when this thing is 0. There are other critical points, but for now, these are the important ones that we know. Okay? And that's it for this example. Let's now move to other subjects.